Hello everyone, today's lesson is 7.3 Integration by Parts. So the formula is integral of u dv. So that's when u substitution doesn't work and you basically have a product of two different things. So then it's going to be equal to uv minus the integral of v du. Now these are a guideline for you to choose what u and v is. So the thing is called Lie 8 and that's for you to choose what u to be. And the first one on the list will be logarithmic function, and then inverse trig function like arc sine, arc cosine. And then the next one is algebraic function. And then t is for trig function. And then e is for exponential function. So if we look at example 1 here, we have the integral of x times e to the x dx. Now notice that if you guys try a regular u sub, right, you could do u equals to x and then du would equal to 1, but that doesn't work, okay? So what you need to do is go ahead and integrate this by parts. So you have two things. You have x times e to the x, okay? So let's look at here to choose what u has to be. Do we have a logarithmic function? No. Do we have an inverse trig function? No. Do we have an algebraic function? Yes, we do. So we're going to let u be x, okay, because that is an algebraic expression. So therefore, we're going to say that du would just be dx. Now the other part is going to become your dv. So your dv is going to be e to the x. How do you guys get v? Well, you need to integrate it, so the integral of e to the x would just be e to the x. So now you just kind of plug it in the formula. So you to the x dx, okay? This is going to be uv minus integral of v du. So what does u equal? That equals x. What does v equal? That's e to the x. And then minus the integral of v. V again is e to the x. And then du would just be dx. So this part is done. X to the e to the x minus, what is the integral of e to the x? Well, it's e to the x again. And then you can go ahead and plus c. So this is your final answer to integrating x times e to the x. Okay. Let's go ahead and try example 2. So let's say that we have the integral of x and cosecant square x dx. I encourage you to pause this and try it on your own, okay? So I'm going to go through my Lie 8 list. Do I have a log function? No. Do I have inverse trig function? No. But I do have an algebraic expression. So that is, I'm going to let u be equal to x. So therefore du is dx. And the other part is just going to become your dv. So that's going to be cosecant square x. And then to get v, you're going to take the integral of cosecant square x, and the integral will be negative cotangent x. So now you're just plugging it in. You're going to go uv minus the integral of v du. What does u equal? U is just x. What does v equal? V is negative cotangent x minus the integral of v. V is negative cotangent x. And then du is just dx. Now I'm going to try to clean this up a little bit. So let's rewrite this as negative x cotangent x. And then you have a minus a negative, so that will be plus the integral of cotangent x dx. The first part, there's really nothing I can do, so I'm just going to rewrite it. And then the next part, what is the integral of cotangent? Well, that's just going to be ln of absolute value of x, and then plus your vitamin C. So then this will be our final answer. Okay. And let's try example 3. So let's say that you guys have the integral of x times ln of x dx. Okay, so same thing. I encourage you to pause this and see if you can solve it on your own. So you're going to say u is equal to, so now this time we have a logarithmic function, so therefore u is going to be equal to ln of x. And then du is going to be the derivative of ln of x, which is 1 over x dx. And then dv is equal to x dx. And then v, you have to integrate x, so this is equal to x squared over 2. Remember, these are just guidelines. There are exceptions. So now you're going to plug it in to, so you're going to go uv minus integral v du. So then u is going to be ln x times v, which is x squared over 2. And then minus the integral of v. V is x squared over 2. And then your u is going to be 1 over x dx. Okay. And I like to clean things up first, so I'm going to clean up x squared and x, so that's going to leave me an x on top. Okay, so then this is going to be equal to ln x times x squared over 2. And I'm going to go ahead and take the 1/2 out, so I'm going to 1/2. Oh, and then I just have x. Okay, so now you're going to get ln x times x squared over 2 minus 1/2. What is the integral of x? That will be x squared over 2 plus c. And I'm just going to keep cleaning this up. Ln x times x squared over 2 minus, this is now going to be 1/4 x squared. And it doesn't really matter that you have minus 1/2 c, because that's just going to be a constant. So I'll just leave that as c. And this is your final answer. Okay, and let's try example 4 here. Uh-oh, how do I, there you go, example 4. So now let's just say I just have the integral of ln x dx. Okay, and so you're going to follow the lineage thing. So you're going to say u is ln x, therefore du is 1 over x dx, and the rest of it becomes your dv. So your dv is just going to be 1. So therefore v is the integral of 1, which is just x. So now following your uv minus integral of v du, your u is going to be ln x. Your v is just going to be x. Then minus integral of v. V is just x. And then your du is 1 over x dx. And then my favorite thing in math is to cancel stuff out. So now we're just going to get ln x times x minus x plus your vitamin C.